Welcome to Spring LIB.
7.33, so we want to show that the scalar product is distributive. Now this is actually fairly straightforward to do if you just write out A, B, and C in terms of being components, and then the fact that scalar addition is distributive, or scalar multiplication distributes over addition, it basically then falls right out. It can be a little bit tedious. But is conceptually very easy to do. The way that the book wants us to do it, it says to use a diagram showing all three vectors in a plane and indicate dot products on the diagram. So we can do that. It's maybe a little bit more interesting. So let's call this vector that's horizontal here A. This vector here is going to be B plus C. Here's B and here's C that are moved to be, C is moved to so that its tail is at the tip of B, so that it's clear that we've added them together to get this vector. So actually, let me redraw this a little bit. Oh. Just to make things a little bit easier. This is the problem with trying to prove something by drawing a picture of a single instance, is that sometimes you end up having trouble, drawing something sort of in a way that's convenient. So if we think about sort of what the dot product is, we can think of it as multiplying the length of A by the lengths of B and C, the components of B and C that sort of project onto A or are parallel to A. So here, for example, is what we could call B plus C parallel. So this is the projection of B plus C onto A, and so then this length times the length of A is the dot product between A and B plus C. But this is, of course, equal to the sum of the projection of B and C onto A. So this is the same as saying that the length of A times the component of B plus C that's parallel to it is the same as the magnitude of A times the component of B that's parallel to it plus the component of C that's parallel to it. And so we see from this that the length here of B plus C parallel is the length of B parallel plus the length of C parallel, which we can, if you like, we can write out here B plus C parallel is equal to B parallel plus C parallel. And so from this, that we can see from drawing a picture like this, and you'd have to technically convince yourself that this is true for any possible arrangements of A, B, and C, but in terms of illustrating the idea, it works. And as we just discussed, the fact that this is true is the same as saying that this is true, because you can think of the dot product as being a multiplication of the length of one vector by the projected length of the other vector.